Okay, welcome. So in this video, we're going to delineate a watershed from a digital elevation model. And um, this video might be a little bit longer than some of the other ones, but I think it's kind of important to have the whole process together. And also because it is kind of a process, I wanted to just kind of walk through it beforehand rather than just going step by step by step. And so basically, we're going to take our original DEM, and then the first thing we need to do is fill any dead-end depressions, because the way this works is it kind of traces flow down the hill. And if there's like a tree throw or like a dam in this creek, that algorithm will just stop. And so we'll get really weird looking watersheds if we don't take those depressions and fill them so that flow is allowed to go downhill unimpeded. From there, we're going to generate a flow direction grid, which tells us which direction water will flow at any given cell. And then we take that and give it to the flow accumulation tool, which this gives us a grid that tells you how many cells flow into a given cell. So for any given cell on the DEM, how many other cells flow to that point. So that'll allow us to kind of see where the streams are, because they're going to have way higher values than cells not on the stream. Then we're going to create a pour point, which a pour point is just where do we want to generate the watershed from. So this is like the point on the stream where we want to generate a watershed for. We're going to make sure, triple check that that pour point is on the stream or river according to the flow accumulation grid, because if it's off even one cell, we're just going to get a little blip of a watershed, not the real watershed. And then we run the Delineate watershed tool with the pour point and another input, which I'll talk about. Then finally, that's going to give us a raster watershed, and we'll take that and convert it to a polygon, which makes it a little bit nicer to view. So let's do it. So this is our digital elevation model. This is prepped already. If you have a really big digital elevation model that you want to work with, you may want to clip it down to a smaller size, because otherwise these tools can take a really long time. We're going to delineate one of these watersheds that we can see that are fully within the DEM. You want to make sure that from the base map or from the DEM itself, be sure that your entire watershed visually is in your DEM. Otherwise, you'll only get part of it. So the first thing we need to do is the fill. So I'm gonna find these tools just by searching. So I'm gonna do fill, and for fill, we just give it our initial raster. So I'm gonna call this DEM fill and run. And so this is gonna fill any depressions that are in the current DEM. And some of these tools will take a little bit, especially kind of depending on how big your DEM is and what the resolution is. So you can see that we have DEM fill here. If you went into Raster calculator and subtracted these from one another, you would see where this made changes on the landscape. For time's sake, I'm not going to do that. In fact, I'm going to remove the original DEM just so I don't mistake it for the filled one. So now we just have our filled DEM. So now we can take that filled DEM and run the flow accumulation, or flow direction, I'm sorry. So if we search flow direction, that pops up there. Surface raster is our filled DEM. Remember to put the filled one in here and not the original if you still have that on. And we'll just call this flow direction DEM. For the watershed, there are other flow direction algorithms. For the watershed tool, we need this to be D8, so just leave that. And we'll let this run. And again, you can see that some of these tools are kind of computationally intensive because they take a second. But this is a relatively small area, so it's not too bad. So now we have our flow direction. So these numbers are associated with a different direction that water will be flowing on the landscape. So you get this nice accidental art thing. So now that we have flow direction, we can do flow accumulation. Flow accumulation is really important just for locating our pour point in the right place, which is a really important aspect of doing this analysis. and I'll talk about why in a second, and I talked about it earlier. But so you can see that the flow accumulation tool wants a flow direction raster. So if you try to skip this step, if you read your inputs, you're like, oh, whoops, need to go back and do flow direction. If you put a DEM in here, you're going to get nonsense. So be sure to put your flow direction from the DEM there. And then we can change, I'm just going to make that flow accumulation. We can just make it flow accumulation. We don't need to do any rasters. Float output is fine. The flow direction that we're giving it is D8 because that's what we ran with that previous tool. So we're going to go ahead and run that. And what we're going to see here, because of the nature of flow on a landscape, is most of the map is going to end up looking black because the basically the majority of the cells have really low values compared to the values that are actually on the stream network. And so we can zoom in and you can start to see that the streams are kind of highlighted, right? Because the streams are the only cells that have a high enough value to actually stand out from the background. And so in this instance, I don't really care where I'm going to generate my watershed from. I'm just going to pick kind of a random spot, but you can, obviously turn these off to look at your original DEM to kind of get a sense of where you want your pour point to be before we do this next step. So the next step here is we want to pick our pour point, and then we're going to use the flow accumulation to make sure that that pour point is in the exact right spot. Okay, so the next thing that I want to do is create my pour point. So I'm going to search for create feature class. And where is create feature class? Right here. I'm going to click that. And what I want to do, so I'm basically creating like an empty shapefile that I'm then going to put a point in. So I want to make sure that I know where this is so I can use it later. I'm just going to put it in my downloads because I'm just putting scrap stuff there. Feature class name, I'm going to call it pour point. Importantly, we want to make sure that we don't want this to be a polygon. We want it to be a point. And coordinate system, I'm going to make it the same as any of these should all be the same. So we can just make it that, any of those. And so it's a point type, name is pour point. It's in our downloads folder. And we're going to run. So now we have this pour point shapefile here, but there's nothing in it. It's empty. So we want to add our point. And so what we're going to do, we're going to click the edit tab up here, click create. Then if we click on the pour point, and make sure this button is highlighted here, which if we hover over it should say point. So we want to sketch points on the map. Now I want to generate my watershed from right around here. And so what I'm going to do is I'm going to go and zoom in to where I want that point. And then we can't really tell exactly where the stream is. So I'm going to turn on flow accumulation. And now we can see where the stream is according to the DEM. So it is crucially important that this point is exactly in one of these highlighted grid cells. If it's off, you're going to get a watershed to this point, not to the stream. So if you chose this, you would just get like these cells right in this location. But if you put it on the stream, you'll get the whole watershed. So I'm going to say finish because that looks good. And then I'm going to click save to save that point. And oops, I think it might have scooted away from me before I clicked it. Save, yes, I want to save my edits. And now we have our pour point on our DEM. So we can zoom out, make sure that's generally where we want to be. That's good enough for me. So we have our pour point, right? We have our flow direction. And so now we want to create our watershed. So I'm going to type watershed in the search, and we're going to go to Spatial Analyst Watershed Tools. So watershed and Spatial Analyst Tools. And see this asks for a D8 flow direction raster. So that was why we made sure that our flow direction was D8. And then you can give it the pour point data as either a point feature or a raster. In our case, it's a point feature. So we're going to give it the pour point. And you can make multiple pour points and do multiple watersheds. We're just doing one. The ID field, if you had several pour points with a lot of data, you could tell it like, I want, you know, let's say there's names for the watersheds, you could tell it use that for the point ID field. And we'll just leave the output as watershed flow 1. So we're going to go ahead and run that. This shouldn't take too long. But what we would expect to see is a raster that kind of covers this area here. Yep. And so that is our watershed. But it doesn't look great as a raster. So we actually want to convert it to a polygon so that then we can kind of make it translucent or just make an outline, etc. So we're going to go up to our search again. And, you know, whenever I'm trying to do a conversion from one thing to another, I always type, okay, it's a raster. So I want to do raster 2. And then you can see that you get a lot of different options. So I'm going to keep typing raster to polygon. There it is, conversion tools, raster to polygon. So we're going to give it our input raster, which is our watershed. Again, we just have the value field. If you had if they had names for them that you wanted to break up different watersheds, you could give it that field. And then let's call this our watershed polygon and click run. So now we're just going to get the outline. So I'm going to go ahead and turn off this. And then, you know, we can take this and turn the flow off or the fill off so you can see the polygon along the watershed. We could use this to clip out the raster or clip out other features, etc. So it's a powerful tool, but it takes quite a bit of steps before you can get to the point where you can just run the watershed tool. And the most important things probably that can get forgotten are be sure you do the fill. We want to make sure that we fill, or else the algorithm won't work properly and this will be a weird shape. And you really want to make sure that you get that pour point on the stream network. That's the whole, notice we didn't use the flow accumulation in the watershed tool. We only used it to put the dot on the stream. If you have a stream network that you've delineated from your DEM, you can use that to locate it. But importantly, I wouldn't recommend using like the National Hydrography dataset or a stream network that was generated from another dataset, because even if that stream is more accurate, the location of it is more accurate than your DEM, all that matters for this to work is that your point is where the stream is according to the DEM you're using. If you're off just a little bit to one side or the other, just because you think that's where the stream actually is, you're just going to get a little sliver of a watershed that's not right. So there's the watershed tool.